So now we're starting off with metallic and non-metallic character and the variation of non-metallic and metallic character along periods and groups. But before we try to understand that, there are some terms that we need to really get into, right? And that's what we're going to discuss first. The first term I want to discuss with you is the ionization energy. Ionization energy. Now, what is ionization energy? Again, not in the textbook, but it will make it very easy for you to understand questions and the basis of metallic and non-metallic character. Now, what is ionization energy? Ionization energy is basically the energy required to remove an electron from the outermost orbit of an isolated gaseous atom. So basically, when we remove electrons from the outermost shell to form cations, right, there is some energy that is required. And this energy which is required to remove that electron from the outermost orbit is what we call ionization energy, right? So ionization energy is the energy required to remove an electron from the outermost orbit to form cations, right? So can you now try to link that with the formation of cations and anions, or basically cations? Let's see. You know that if we have a low ionization energy, right, if we want to spend less energy, right, that's always what we prefer, right? We want to always spend less energy, less money on things to do. So basically, it is always preferred that the ionization energy is less for the formation of a cation to take place. So you know that metals are the things which lose electrons, the substances, the elements that lose electrons, and hence metals have low ionization energy, right? Metals have low ionization energy. That's pretty obvious because metals lose electrons much more easily than non-metals, and hence they have low ionization energies. We don't have to spend much energy to remove electrons. Whereas non-metals have high ionization energy because obviously non-metals don't really lose electrons, they actually gain electrons. So non-metals have a high ionization energy, whereas metals have a low ionization energy. Okay. One more thing to be understood here is the relation between ionization energy and atomic size. Ionization energy is inversely proportional to the atomic size. So if you have a high atomic size, then ionization energy will be less, right? That's pretty much it. Now let's try to look into the variations of ionization energy along groups and periods. So let's have a look along a period. Now you know that along a period, as we've discussed earlier, the atomic size decreases. Right, we've discussed this earlier that the atomic size decreases as we go from left to right in a period. So since atomic size decreases, your ionization energy will increase. Ionization energy will increase. Okay, ionization energy will increase. Now since ionization energy will increase, what happens? The tendency to lose electrons decreases. Why is that so? Well, if you have a high ionization energy, a lot of energy will be required in removing an electron, and hence it will become difficult for an atom to lose electrons. So An increase in ionization energy will mean that the tendency to lose electrons will decrease. And if the tendency to lose electrons decreases, then which character will decrease? Metallic character will decrease. Metallic character will decrease. And why is that so? You can pretty much, understand that because metals lose electrons. And if you lose electrons easily, that means you have a high metallic character. But if you lose electrons less easily, then you have a lower metallic character. Or you may have a high non-metallic character. Because non-metals have a tendency to gain electrons and a very low tendency to lose electrons. Right? So a longer period, your tendency to lose electrons decreases and hence your metallic character decreases. So what can you infer? Obviously, your non-metallic character will increase. Non-metallic character will increase. Right? So that is the variation of ionization energy and subsequent repercussions along a period. So you can see how one concept is linked to one another. Atomic size linked to ionization energy, linked to the tendency to lose electrons, linked to the metallic and the non-metallic character. So you can see how we link everything, right? So that is the beauty of variation of properties along a period. Next we come down a group. So down a group, as we've discussed previously, down a group, the atomic size increases. So down a group, atomic size increases. So what will happen? Your ionization energy is inversely proportional, so it will decrease. Ionization energy decreases. Now, since your ionization energy is decreasing, electrons will be lost more easily. So, tendency to lose electrons increases. Increases, and hence what will increase? Your metallic character will increase. And what will decrease? The non-metallic character will decrease. Right? So that is your ionization energy and its subsequent effects along a period and down a group. Right? So that is with your ionization energy. I hope that's absolutely clear to each and every one of you. Now we come to the next concept which I want to discuss, and that is electron affinity. Electron affinity. Now this is another term not there in the textbook, but again the presence of this concept helps you to really identify the thing really clearly. Right now you can see how easily you can formulate a structure and explain valency, explain atomic size, explain ionization energy, explain effective nuclear charge, and explain metallic and non-metallic character. Right? So now electron affinity. The affinity for an electron, the love, the want, the need for an electron. So basically it is defined as the energy released, when an electron is added, to the outermost orbit, of an isolated gaseous atom. So the energy which is released when we add an electron, right? When we add an electron, some energy is released. And that energy released is what we call electron affinity, right? Now, that is what we call electron affinity. So let's try to, understand electron affinity now, right? Now, electron affinity electron affinity enables loss of electrons. Sorry, enables gain of electrons. So if you have a high electron affinity, then that means that you have a higher tendency to gain electrons, right? Because since more energy is released, that means you have a higher tendency to gain electrons, right? So your metals have low electron affinity. Low electron affinity. But your non-metals have high electron affinity. High electron affinity. They have a high tendency to gain electrons, right? Hence, they have a high electron affinity because they want more electrons. They have an affinity for electrons. Okay, so that is your high electron affinity. Now let us try to understand the variation along a group and period. So along a period. Now before we go on to the period variation again, let's have a look at the relation between atomic size and electron affinity. Just as we discussed ionization energy, just as we discussed effective nuclear charge, in the same way, your electron affinity is inversely proportional to atomic size. So if you have a low atomic size, you have a high electron affinity. And you have a high electron affinity, you have a low atomic size. And you have a high atomic size, then you have a low electron affinity. Right? So let's try to understand that now. Along a period. Now, along a period, your atomic size decreases, right? Atomic size decreases. Now, since atomic size decreases, as a result, your electron affinity will increase. So, electron affinity increases because they are both inversely proportional. So, electron affinity increases. Then, your tendency to gain electrons increases. Tendency to gain electrons increases because electron affinity basically ensures that the gain of electrons is smooth. It is, very easy. So that tendency to gain electrons increases with the electron affinity, unlike the tendency to lose electrons with ionization energy. Okay, they are inversely proportional, but the tendency to gain electrons and electron affinity, they are directly proportional. So tendency to gain electrons increases, hence what will increase? The non-metallic character increases. Non-metallic character, that is, they have a tendency to gain electrons, that character increases, and ultimately metallic character decreases. Right, so that increase and decrease of metallic character can be explained with the use of ionization energy or with the use of electron affinity as well, right? Next thing, down a group. Down a group. So down a group, how does your electron affinity change and how does it affect other properties? So again, as we know, your atomic size increases. Atomic size increases. Now, as a result, your electron affinity decreases. Electron affinity decreases because they are both inversely proportional, as I said before. Next, tendency to gain electrons will decrease. Tendency to gain electrons decreases. And ultimately, your non-metallic character will decrease. Non-metallic character decreases. And ultimately, as a result, your metallic character will increase. Metallic character increases. Right? So this is the variation of electron affinity along a group and down along a period and down a group. And summarizing all of this, let us come to metallic character, which is the last periodic property we will be discussing, metallic and non-metallic character. And as I have explained by using electron affinity and ionization energy, I don't think you should have any kind of problem at all now. First is a longer period. Now, as I have discussed above so many times, I have written this down, and now I think you should understand how it happens too. If you still have it out, please let me know in the comment section, but I'm just going to write it out directly. Along a period, your metallic character decreases. Metallic character decreases. In brackets, I am writing this because metallic character is electropositivity. Right? Because you are electropositive. Metals are electropositive. They have the tendency to lose electrons and form cations. Hence, they are called electropositive elements. And if metallic character will increase, we can say electropositivity will decrease. Electropositivity decreases. And non-metallic character will increase. Non-metallic character increases, and here you can say electronegativity, that is the property of non-metals, that is to form anions by gaining electrons, by pulling electrons towards themselves. Electronegativity increases. Right? So that is with your period. Next comes the group. Down a group. Down a group, your metallic character will increase, as we have discussed above. How? Metallic character increases. Okay, and here you can say electropositivity increases. Electropositivity increases, and your non-metallic character decreases. Non-metallic character decreases, and hence you can say your electronegativity decreases. And that's with the chapter. Right? So with that, we complete the chapter periodic classification of elements. Thank you for joining me in this series. And if you have still any kinds of doubts, please leave them in the comment section below. Do like and subscribe, and please like my new Facebook page, that is Jaideep Singh's Interactive Education. And to connect with me, please like that page, subscribe my channel, and any doubts are welcome in the comment section below. Thank you very much. Like, subscribe, and bye-bye. Stay healthy, stay smart, and do keep studying.